here we go. We're going to learn how to name some more, but these particular compounds have transition metals. And I already told you they're a little wacky, so they take some extra time. But you still need these materials in front of you. Your periodic table, that concept map, and polyatomics. Just like we did group A metals in the previous video, we're still looking to see what is in my compound by using that periodic table. These ones are going to be highlighting transition metals attached to nonmetals and transition metals attached to polyatomics. They are named exactly the same way. There's just an extra step in transition metals, and that is to express the oxidation state of the transition metal. We have to tell the reader what is that charge of that transition metal. That's what the oxidation state is. And so we're going to have to calculate it like in the video that I showed you how to do. So let's take a look at our concept map. Transition metal attached to a nonmetal. It says name that metal, chromium. And when you're naming a transition metal, immediately put parentheses behind it to remind yourself you have to go in and calculate that. I call that the ka-ching because that's the winning points for you. All right? So name the transition metal and then ka-ching, and then name the nonmetal with an "ide," chromium oxide. We know that in a previous video we draw what the anion, the negative part of the compound, is. We know those charges on that compound, and we know that the cation has to balance out that negative part. So with those two oxygens being a total of a -4, we know chromium has to be 4. And we express that in Roman numerals of IV. So this is chromium 4 oxide. All right, let's go to this next one. Transition metal to a nonmetal. Name that zinc. Ka-ching, so you remember to go in there. Name the nonmetal with an "ide," chloride. Each chlorine is a -1. You can read that charge off the periodic table. And I have 2 of them, so 2 times -1 is a -2. Zinc then has to be a +2 to balance that out. So zinc is zinc 2 chloride is its answer. Okay, let's take a look at this one. We're going to name it. That's gold. Ka-ching, so we know to go back there to do that. Fluoride, F-L-U-O-R-I-D-E. Again, off to the side, you can draw gold with 3 fluorines attached to it. Each one is a -1. That means I have a -3 in my part of this compound. Gold has to counteract that by being a +3 charge. And then when I name it, I make sure I express that to the readers, that gold 3-fluoride is the answer. All right, now let's take a look at transition metals attached to polyatomics. They're done exactly the same way. You just have to recognize those polyatomics. You have to have those charges memorized, or this part becomes very difficult to do. So again, I'm going to name my metal, which is iron, ka-ching. And then this one on the concept map says name the polyatomic. NO2 is nitrite. All right, I have to go back in and calculate what that charge is on iron. You're still drawing the compound. I have 2 nitrites attached to iron. I have to memorize that the nitrite polyatomic has a -1 charge. So a total of a -2 charge, which means iron has to be 2. Okay, that's what charge it's going to be in this compound, is a +2. Let's take a look at this base here. Remember, OH tells you it's a base. I'm going to name that. That is silver. Ka-ching, right? And then name that poly is hydroxide. Now, if students don't know that that's a polyatomic, I will get silver, oxygen, hydride or something. So that's why you really have to know those polyatomics. Again, you have to recognize that the hydroxide as a group has a -1 charge to it. That means silver has a +1 charge to it. Okay? All right, let's take a look at this one. That looks like a pretty long one to write, but that's still a transition metal attached to a polyatomic. So that is manganese. That is not magnesium. And then we go ka-ching. And we can name that bisulfate, or you can name that hydrogen sulfate. Healthcare workers should know that it's bisulfate because that's how you'll hear it in the hospital. All right, so I'm going to take a look at bisulfate. I know, because I have them all memorized, that that's a -1 charge for each of them. And there's 5 of them attached to manganese. So 5 of them with a -1 charge means it's a -5, which means manganese has to be a +5. So I express that as a V, the Roman numeral for 5. Manganese 5 bisulfate. So these are the rules that you're going to follow when you're naming transition metals, exactly the same as group A metals. You just have to remember the ka-ching part of the naming of the compound, and it helps when you draw it out in order to see what that negative total amount of the negative charges in the compound and what the cation, the transition metal, has to have in order to balance that out. And it takes practice, so we're all here to work together. So let's start.